All right, what's up, everybody? We're going to talk about integration right now. So this is an integral. So this is just like super intro based. What are the steps? And at the end, we're going to talk about what does this thing actually mean. But for now, I feel like you only care about the steps. So let's just get that done. So, okay, you're going to see these two scary looking things. This like squiggly s and this dx is going to sandwich some type of function. Okay, so let's just go over the steps. The steps to integrate is pretty simple. So basically it's the opposite of taking a derivative. So the first step is to add 1 to this exponent. Okay, so that's the first step. So this is going to turn into x to the third power. After that, you're going to divide it by this new number. So you're going to divide it by 3. Okay, this next step is going to be kind of weird. You're just going to add c. Okay, don't get scared. Don't get scared. It's going to be okay. Those are all the steps to take this integral. So you're going to add 1 to the exponent, divide it by the new number, and then add c. I'm going to explain this later. So basically, what's happening is this is the opposite of taking a derivative of something. So if you were to take the derivative of this, you're supposed to get whatever number was back here. So let's just check them to make sure we did it right. Let's take the derivative of this. Wait, hold on. I forgot to say c is just a constant. So c is just a random number. It could be 5, could be 100, could be 500. Doesn't matter. Whatever. So let's take the derivative of this and see what happens. So if we take the derivative starting here, we bring this 3 out to the front, then it's x, subtract 1 from here, squared, and then it was all over 3, right? When we take the derivative of any number, say it's 5, say it's 100, whatever, it's going to be 0, right? So plus 0. So this is going to turn into x squared. Okay, see how we did that? So that's basically what is happening with derivatives and integration. A derivative gets you this way. An integration or an integral gets you back the other direction. So let's try another example to kind of get a little bit more familiar with it. It's okay to be feeling really scared right now. All you need is just a little bit more practice and it's going to be okay. So now if you notice in this one, there's 2 different things. So we're going to just do the same thing, but we're going to add the 2 together. Let's start with this one. We're going to leave this 4 the same. You leave whatever is being, if there's a number multiplying the x, you just leave it out. So you're going to leave this 4 out, okay? This x has an imaginary 1, right? So it's 4x, and then we add 1 to the imaginary 1 that's right here. So that's going to turn into 4x squared. And then the next step, remember, is to divide it by 2, because that's our new number. Then you might be like, okay, now is it time to add c? We're going to add c at the end. You do this whole thing right now. C is just like a number, it's just like a placeholder for a possible number that could be there. All right, 3, we have a constant here. If you ever have a constant, you're just going to add an x to it when you take its integral. Why? Because that's a great question, actually. So x to the 0, what does that equal? That equals 1. So there's an imaginary 1 being multiplied here. X to the 0, you do the same thing. You add 1 to the 0 here. There's an imaginary 1 here. It's dividing it by 1. That just leaves us with 3x. Okay, now you can add c. Don't be scared. It's okay to be a little bit confused right now. We're just going to keep going through these and explaining them one by one, and I promise you're going to get the hang of it. Okay, so if we simplify it, that turns into 2x squared plus 3x plus c. Again, if we take the derivative of this, it's going to give us 4x plus 3. All right, see how we did that? Let's do another one. This one looks a little bit different, right? Because it has these numbers here. This is... Okay, I didn't tell you about the numbers at first because I didn't want you to get scared. It's not that bad. We're going to deal with them at the end. So For now, let's do the same thing that we've been doing. Okay, so let's deal with this one first. Remember, we leave the 6 the same. X to the 1 is here. So we're going to add 1 to this. That's going to give us x squared. Then we divide it by the new number, right? So that leaves us with 6x squared over 2 plus 4. And then remember what we do with constants. We just add an x, right? Which makes sense because the derivative of this is just 4. Okay, so we don't add c with numbers, and I'll show you why. Okay, what does this mean? There's another step when you see numbers. If there was no numbers here, we would just add c and call it a day. But if there's numbers here, that means there's one more step. Okay, what does this mean? This little line here you're going to see with 0 at the bottom and 2 on top, or whatever numbers are here, means you're going to plug 2 into wherever there's x's, find that number, then you're going to subtract that number by what happens when you plug in 0 to here, whatever number's on the bottom. So let's do it. What if we plug in 2 to this whole thing first. So, all right, so if we simplify this a little bit, it's going to look like that. Now let's plug in 2. That's going to turn into 4, right? Plus 4 times 2. Okay, so that's what's happening when we plug in 2. Now we have to subtract this number by the number we get when we plug in 0. So subtracted by 3 times 0 squared plus 4 times 0. So if we simplify this out, this goes to 12, this goes to 8, and then this goes to 0, so minus 0, which is just equal to 20. So 20 is going to be the answer for the integral of this. So I'm going to explain what that means later at the end of the video, like what 20 actually represents, but those are the steps. So let's try another example. Okay, let's try this example. So let's evaluate this. There's a 1 here, so we leave the 2 the same times x, and then we add 1 to the 1 that's already there, which gives us a squared. Then we divide this by 2. Okay, that's that one. Now we add, oh my gosh. Oh, wait. Okay, wait. I forgot to, okay. Just realizing that I forgot to talk about where the c goes in the last one. I'm going to talk about it in this one. Okay, plus 1 times x. Okay, so that's going from 1 to 3. So let's simplify this a little bit. Okay, so now we're here and we have to evaluate it from 1 to 3. So now you might be asking, wait, bitch, you forgot to talk about what happens when, like, why we didn't add c. When we plug this 3 in and then plug this and then subtract it by what happens when we plug this 1 in, what happens? So let's say there was a c. We plug this in. This is going to have plus c, right? Then you're going to subtract it by what happens when you plug in 1. Okay, but in this case, if we added a c, these c's are going to cancel out because this negative side distributes to this one and it cancels out. So worst case scenario, you write a c and they're going to cancel out. But that's just why we say with the numbers, because we're subtracting like 2 of these basically, the c's are always going to cancel out and you don't need to worry about it. Okay, again, we're plugging in 3, okay? That's 3 squared, which is 9, plus 3. Okay, now we need to subtract what happens when we plug in 1 into this little equation here. So 1 plus 1, okay, that was so hard, equals 10. Okay, that's the answer. Okay, so do we see what's kind of happening here? There's a ton of practice examples online, but we're just going to like walk through the basic steps right now. So let's try another. Oh, fuck. Okay. This is so scary looking, right? This is so scary looking. Even I'm a little bit scared. Don't panic. Don't panic, okay? Don't cry. If you're already crying, I'm so sorry. And I promise that you won't be thinking about this in the big important moments of your life that actually matter and have meaning. This is just something that you need to get through. And it's going to be okay. We're going to get through it. There's some that you need to just memorize that don't have like a specific formula of adding 1 to the exponent and then dividing it by that number. So let's take a look at those really quick. Okay, so these are some that you just might want to memorize. So if you have if you're asked to take the integral of sine. Your answer is going to be negative cosine of x plus c. Okay, that makes sense. Wait, no, it doesn't yet, but it'll get there. Let's see why it makes sense with cosine. If we take the integral of cosine, that's going to give us sine plus c. Why? Because what happens if we take the derivative of sine plus c? Well, the derivative of sine is, you guessed it, cosine, and then plus c, that's just like a number. Bye! These, I literally forget about this all the time. Just memorize it. E to the x is a queen because it stays e to the x. Okay, memorize these. Sorry. I am sorry. Okay. Let's try examples with these. So, this one here, we leave the 3 the same, right? X, and then we add 1 to this exponent, so x cubed. Now we divide it by the new number, so divided by this number, which is 3. Now this one, okay, we leave the 4 the same like we do normally, but then it's e to the x. Look, e to the x is here. The integral of e to the x is e to the x. Sus as fuck, but let's just roll with it. Okay. Now there's no numbers, so we can just add plus c and we're done. So this is the answer for this one. Okay, let's try another. Okay, now let's go. Okay, this one, we leave the 4 the same, then x, there's a 1 here, 1 plus 1, 2, okay. Then we divide this by 2, cool. Now we have this one. Minus sine. What is the antiderivative? Oh, antiderivative and integral are like the same word, basically. Okay, this goes to this. Okay, so minus cosine of x, babe. Okay, and it's going from 0 to pi. So let's simplify this a little bit. It's going to give us 2x squared plus cosine of x from 0 to pi. All right, let's plug and chug, baby girl. So we plug pi in. That's going to give us 2 pi squared plus cosine of pi. Then we're going to subtract it by when we plug in 0. So 2 times 0 squared plus cosine of 0. Okay, so what does this give us? This gives us 2 pi squared, which I don't know the answer of. We're just going to leave it like that, plus cosine of pi. Cosine of pi is negative 1. So this is going to turn into negative 1 minus, now what's this? Okay, 2 times 0 squared is just 0. What's cosine of 0? Cosine of 0 is 1, right? Yeah, okay. So when we simplify that out, that gives us 2 pi squared minus 1, and then minus 1 here, right? Minus 1 when we simplify it. So our final answer is 2 pi squared minus 2. Okay, that was hard. But now we have it, right? So what we're going to do is we are going to talk about what the fuck that actually means. So let's go to a more nice looking example. Pranked. Let's do one more. Okay, we can do it. This one's easier. Okay, what is the antiderivative of this? Did you say ln? I don't know. Ln of x, babe, plus x, add 1, right, to make it 2. Divide by the new number. There's no numbers here, so it's going to be plus c. Okay, so easy. We're literally so good at this. Okay, so let's talk about what's actually happening graphically here. So here's a graph. What integration means, this is a graph of x, this is like the graph of x. So what's happening here in the graph is basically, okay, here's this function, babe. Find out the area underneath this function from this point to this point. So basically, if this is the function, what this antiderivative is asking you to do is find the area from 0 to 2 underneath that function, like in between that function and the x-axis. So if you notice, this makes a triangle, yeah? Where the base is 2 and the height is also 2. Okay, well, the area of a triangle is base times height divided by 2. So that's going to be 2 times 2 over 2, which is equal to 2. So the answer to this should be 2. But let's check it algebraically. So we add 1 here, right? That gives us x squared, and then we divide it by the new number 2. Okay, that's being evaluated from 0 to 2. When we plug in 2 here, it's going to give us 4 over 2, and then we subtract it from when we plug in 0, which is equal to 4 over 2, which is equal to 2, bitch. Isn't that cool? Okay, so integration is hard, and this is just the intro to integration. You're going to start to see a bunch of stuff that looks like this. This is just more advanced integration, and I'm going to cover that in my next integration video. Make sure to hire me to tutor you, and I promise you won't fail math. Okay, love you, bestie. Gotta go. Bye!